Hello and welcome to Vodcast 2.6b. This is part 2 of the frost wedging demonstration, and we're going to see the results of my little experiment. Let's head to the fridge and see what happened.
Can't stop, addicted to the shindig. Chop top, it says I'm gonna win big. Choose not a life of imitation. Distant cuts into the reservation. Defunct the pistol that you pay for. This punk the feeling that you stay for. In time, I want to be your best friend. Eastside love is living on the west end. Knocked out before you better come to. Don't die, you know the truth is some do. Go write your message on the pavement. Burn so bad. I wonder what the wave meant. White heat is screaming in the jungle. Complete the motion if you stumble. Go ask the dust for any answers. Come back strong with 50 belly dancers. The world I love, the tears I've dropped to be part of the wave. Can't stop. Ever wonder if it's all for you? The world I love, the trains I hop to be part of the wave. Can't stop. Come and tell me when it's time to. Sweetheart is bleeding in the snow cone. So smart, she's leading me to ozone. Music, the great communicator. Used two sticks to make it in the nature. I'll fit you into penetration. The gender of a generation.
On this slide, I've inserted two close-up pictures of the results that you just saw. In summary, the glass vial containing the water broke into two pieces when the water inside froze, but the glass vial containing air did not break. It was just really cold to the touch. Put simply, this lab demonstrates the awesome power of water. Let's review some really important concepts that help explain the results of this experiment. The first science concept I like to highlight is density. Water ice is less dense than liquid water, and that's why your ice cubes float in a cup of ice water. Now, because water is less dense in its solid form, that means that liquid water has to expand when it freezes. That vial containing water was a pretty small vial, and the glass was pretty thick for the size of the vial. So I gotta admit, I find it pretty awesome that the water inside of that vial can break the glass as it expands and freezes. As a really rough and maybe overdramatic analogy, think of Bruce Banner getting stuffed into a casket before he's actually dead. If he suddenly changes into the Incredible Hulk, the amount of space he takes up is going to rapidly increase. And when that happens, he's going to burst through the casket and shatter it into pieces. You can kind of think of water as doing the same thing. When it freezes, it takes up more space, and as water freezes and expands, it exerts an increasing and outward pressure on the walls of the glass container. Eventually, that outward pressure is strong enough to break the glass. Now, air behaves a little bit differently. Specifically, warm air is less dense than cold air. And in this particular experiment, the air started at a fairly warm temperature and then it cooled down when it was placed in the freezer. Because cold air is more dense than warm air, cold air will occupy a smaller volume than warm air. You can kind of think of the air as shrinking as it gets cooled to lower temperatures. You may have noticed this in your everyday life if you've ever seen a balloon that's shriveled because of colder temperatures. It's the same amount of air inside the balloon, that air is just now occupying a smaller volume because it's colder than it was previously. It's also worth mentioning that the air was a gas when we put it in the freezer, and it was still a gas when it cooled down. In other words, the air remained a gas throughout this demonstration. So in summary, water can be a very powerful mechanical weathering agent, especially in regions where there's freezing and thawing occurring throughout the year. If liquid water seeps into a crack in a rock and then freezes, the expanding water will exert pressure on the inside walls of the rock crack, and as a result, that rock can get broken up even more. This process, which we call frost wedging, helps explain why we see potholes and cracks in our roadways here in Illinois. Because for our particular climate, we will see liquid water during the warmer months, and we will see frozen water during our cold months. Okay, thanks for watching, and I hope this video is helpful in understanding a very important mechanical weathering process, which we call frost wedging.
Can't can't stop